Okay, thanks everybody for joining us tonight. This is our third in our 2025 heat pump webinar series. Tonight's webinar is all about heat pumps for existing homes with ducted heating systems. We'll also touch on heat pump water heaters towards the end of the presentation. My name is Diego Betts. I am the Residential Energy Programs Coordinator here at Walking Mountains in Avon. We are talking all about ducted heat pumps tonight, and I'm joined by David Petroy. David's based down in Boulder, and I'll introduce him in just a couple of minutes here. Just a few housekeeping items before we get started. Just so everybody's aware, this webinar is being recorded. We will upload the recording to YouTube within a few days after the webinar. So if you can't make it for the whole thing, you can watch at a later time. We'll also follow up with an email with a link to this recording, some additional information about heat pumps, as well as local rebate incentives, and all of the slides from tonight's presentation. We will have time for Q&A at the end of the presentation. We ask that you put any questions you might have into the Q&A function that you have down at the bottom of your screen. If you're experiencing any technical issues, please send us a chat, or you could also raise your hand and we can address that issue. So just getting started here. Again, tonight's all about ducted heat pumps. It's the third in our 2025 webinar series. Right here is a list of all the webinars that we've put on so far and we will be doing in the future. And you'll be able to access the link to our YouTube playlist down at the bottom once we send the slides out. So you can watch all of these recordings when they're uploaded. I want to give a big thank you to all of our sponsors for this series for this year. We have the Beneficial Electrification League of Colorado, Energy Smart Colorado, Holy Cross Energy, Tri-State Generation and Transmission, CORE, or the Community Office for Resource Efficiency, which is an Energy Smart partner in the Roaring Fork Valley, and CLEAR, Clean Energy Economy for the Region, which is an Energy Smart partner in Garfield County. We wouldn't be able to do all of this without you. We've been able to reach a big audience thanks to all of the support we have from our sponsors. So thank you all. Going to go through a few of our resources and some information about rebates before Dave gets started here. So loveelectric.org and the Beneficial Electrification League of Colorado have lots of great resources online for both homeowners and contractors, technical resources. They put on trainings. Homeowners can search for any and all rebates available in their area. They can find qualified contractors, as well as just more information about electrifying your homes. Energy Smart Colorado is a huge partner of ours. We run the Energy Smart Colorado program in our area in the Eagle River Valley through Walking Mountains. They have lots of different partner organizations throughout the state. And you can see they cover a big portion of the western slope of Colorado. And Energy Smart's collective goal is to make residential and commercial energy efficiency improvements simple and affordable, while they advance community-based goals for energy efficiency, electrification, and climate action. So thanks so much, Energy Smart, for all of your support. We're happy to partner with you. Here's a slide about some rebates available from our local Energy Smart partner nonprofits up here in Eagle County, Garfield County, and Pitkin County. So CORE is the Energy Smart partner in the Roaring Fork Valley. They have rebates both for existing homes and for new buildings. They also have some bigger rebates for income qualified homes. Clear helps customers in their area get rebates from Glenwood Springs Electric, and they also have income qualified rebates. And they also help facilitate rebates for Xcel Energy for folks who have Xcel in their territory. And then Walking Mountains also offers rebates for qualifying cold climate heat pump systems. We do both residential and commercial rebates. And we do have an income qualified energy program called Reenergize Eagle County. So if you have any questions about any of these offerings in your area, please don't hesitate to reach out. Holy Cross Energy has great rebates for folks who are Holy Cross members. They will rebate qualifying heat pump installations. They have bigger rebates for income qualified households, and they also do commercial and multifamily building rebates. Holy Cross Energy will also rebate all electric new construction. Tonight's webinar will be focused on existing homes and retrofit projects, but if you are building a new home in Holy Cross territory, definitely reach out to them. If you want to go all electric, they've got great incentives. Holy Cross Energy also has a new on-bill repayment program for heat pump installations. You can finance up to $15,000 at 0% interest over 10 years for cost of installing a heat pump. They stack all of the incentives up front, work with contractors, and get you set up with a great heat pump system at very low or no upfront cost. Tri-State Generation and Transmission also has a great on-bill repayment program for heat pumps and other energy efficiency measures. They have low interest rates, terms up to 10 years, and there's no credit check required. It's not available in all of their locations yet. Currently, the San Luis Valley, Gunnison County Electric, and Sangre de Cristo Electric customers are able to participate, and it's coming soon to White River Rural Electric customers. They also do have some bonus incentives if you participate in the on-bill repayment program. For any of those measures, you can get those bonuses on top of existing incentives. Xcel Energy has all-electric new home program. So if you're building a new home in Xcel territory, definitely reach out to them and learn about their incentives and requirements for zero energy ready homes and the Energy Star Next Gen certifications. Xcel also has great rebates for retrofit projects, which tonight's webinar will be focused on. You can see here for cold climate air source heat pumps, they will rebate based on the size of the heat pump and its capacity at those low temperatures. Definitely reach out to Xcel Energy if you're considering a heat pump installation and you have Xcel gas or electric service. And this is Dave Petroy. So Dave has well over 15 years of experience in a range of renewable energy and sustainability business roles. He was the founder and president of Blue Valley Energy, a successful ground source heat pump engineering, design, and installation company in Boulder, with over 200 installations throughout Colorado. During the early 2000s, Dave led technical sales of solar and energy power systems for residential and small commercial businesses at RMS Electric. And at Golden Aluminum, which is one of the largest single-site industrial power users in Colorado, David was responsible for leading the adoption and implementation of facility-wide energy monitoring systems and upgrades to reduce energy consumption on large industrial production processes. Recently, Dave has done consulting work with Xcel Energy, helping their customers understand their energy usage. And in 2017, he launched NTS Energy, a consulting company focused on providing advanced HVAC and solar solutions to homeowners and small commercial companies while promoting the transition to the new energy economy here in Colorado. Dave holds a master's in geophysics from Washington University in St. Louis and a bachelor's in zoology from SUNY Oswego. So, Dave, thanks so much for presenting tonight, and I will hand this over to you.
Thanks, Diego. Welcome, everyone. Let me just put up the share. We've got quite a bit to cover tonight. Usually it takes about 35 minutes to get through the presentation. We'll go from a high level, get in the weeds a little bit on some critical stuff. So we're going to talk about the benefits and the costs, understanding some of the specifics there. Then we're going to go review how to get a good heat pump system. And then he's already covered a lot about the rebate programs and local incentives. So for those of you who don't know, real quick view of the heat pumps. Diego, can you see the screen here? Just double check it.
Yes.
Okay. So this is quickly how it works. You've got an outdoor unit, you've got an indoor unit. A lot of people say, well, how can I get heat from when it's really cold out? What happens is we'll start at the bottom where the refrigerant comes through a line that's connected between the indoor and outdoor unit. It starts here and it's cold. It's very cold. Goes in here. Cold is well below zero. And it's basically coils are around here. The air blows across and energy moves from hot to cold. So it heats up, turns into gas. And these are some of the properties of refrigerants that are very special, how well it changes states and how much energy it can absorb. So it absorbs quite a bit of energy and it comes up into the compressor as a gas. And the temperature that's going to depend on the season of the year. And I'll show some numbers about that. But, it's in the spring and the fall, this gas is a lot warmer than what's in winter. So then you put some energy in. You compress it because you need this gas to be anywhere from about 95 to 110 degrees to have enough heat to heat your house. It comes in as a warm gas. There's a coil up in the top of the unit. Basically, the air blows by this gas and it goes and heats your home and gets cooled down, comes out here. And then the real trick at the bottom is this expansion valve. What happens is that in that valve, the refrigerant is expanded. And when you expand a refrigerant or a gas, it cools down quite a bit. So that's the other key part, is it dramatically cools, goes here. Now, the funny thing, or the interesting thing, this is just a reversible air conditioner. So the only thing really in here is called a reversing valve. Makes it a little more complicated how it does it, and a little bit of controls. So one of the things, the reasons we're here today, and 20 years ago we couldn't have been, is there's been just this, the industry's dramatically improved. Efficiency, there's ability to defrost. It used to be when it was cold, icy, things would freeze up, couldn't defrost. You've got higher capacities and efficiencies, and you've got the ability to heat below zero. So let's talk really quickly about a couple of those things. So first of all, I'm going to get my timer going here so I know how far advanced I get. This graph shows, and the bottom is outdoor temperature. On the left, it's 0 to 70. And the vertical axis is how much heat that a home needs to be heated. And I've put in just kind of a typical home size, say 2,500 square feet. And this green line is how much heat's required to heat that home up to 70 degrees. And so originally, say about for many actually before 2000, this thin blue line here cutting down across the middle, that's what heat pumps could do. And they were in a few zones in the South where it never got cold. And you can see above 30, it has enough capacity to heat. It crosses the green line. So over the last 10 years, we've been improving these. And the red line is kind of where we'll call them tier 1. They now, and some of the other ones, they have the capacity to go down to 20 degrees. And then cold climate heat pumps, they hold their capacity. They basically hold it all the way to 0. And actually now they taper off, but they hold their They can heat all the way down now between -13 and some of the units out -15 and -20 of the major manufacturers. So they can provide most of the heating. This little box here is the little gap that we'll talk about ways to supplement the heat pump to do those. Looks like a lot here, but I'll show you it's really very little. So this is the capacity because you couldn't really use them in Colorado when they were down here. Number two is efficiency. And HSPF is called heating season performance factor. Two, they've just redone it, made it more accurate. And the vertical axis, the higher the number, the better. 12 is twice 6. And this is from 2012 to 22. I have to update it. 24, there's a couple that are a tiny bit more, but in general, they've about here because they've been changing over refrigerants. And so the blue is the actual HSPF, and this is the improvement in efficiency. And so really, right now, you get between about most of them are around 25, 35% improvement. So that translates directly into costs to heat throughout the year. In existing homes, you really got two options. Left side is going to, let's say it's an all-electric system. You got a unit on the outside. You got refrigerant lines running to the inside. You've got a unit that looks like size and shape of an old gas furnace. No gas inside, but inside it will be electric strips, heaters that is supplemental. The other option is called a dual fuel system. It's got a furnace in it with a coil at the top, similar to an air conditioner setup, except like I said, the only difference is this has a reversing valve. And here's just this is the inside unit, pretty typical. And here I like this, I grabbed this picture from LeBlanc, quite nice, because it's got, there's sort of two styles of cold climate heat pumps. You've got this more rectangular and more square style. So what are the benefits of a heat pump as your primary heating source? Well, one is it's got cooling and heating in the same unit. There's much less energy use. Reduces your heating bill versus continuing heat with electric or propane by a lot. I'll show some numbers. Natural gas, it's potential savings and back and forth, but it's kind of insurance. If you got a dual fuel, you have the ability to change over from gas to heat pump and back and forth a little bit. It significantly reduces local air pollution. A lot of people talk about GHGs, but really you got NOx, NO2, VOC, sulfur, particulate matter from your home. Up in the high country, you guys have much cleaner air than down here, but we've, in the Front Range, we've got these issues, and you've got GHG emissions reduction. So make sure we're on the same page. I was thinking about it while Diego was introducing. I really should have a page showing like what's shown on the manufacturer's websites. You've got my thermometer here on the left side is lower efficiency to higher efficiency. You've really got kind of four unit types of heat pumps. Well, you could call these as one, but I've got single speed, I've got dual speed or capacity or two stages. I've got variable speed capacity inverter systems. I've got variable speed capacity cold climate. Start at the bottom. What's the difference? Well, the single and two stage are obviously lower efficiencies, lower costs. They're really for ducted systems only. They're not adequate for an all-electrical heating system because they tail off. And if you've got natural gas on site for an existing home, which most do, or other reasons for new homes, you've got a dual fuel option. These are variable speed capacity inverter systems that are not technically defined as cold climate. They heat down to zero. They also tail off. And that's the big difference between these two, is the tailing off of the capacity. Again, they're not quite adequate for all electric heating in Colorado, maybe in climate zone 4, the mildest climate zone. Most in the high country, you're 5, 6, and actually 4 is kind of a push. But it's great for dual fuels again. And now you've got what are called the cold climate. And they're for all electric. They can hold capacity at low temperatures. They can heat down to minus 13 has kind of been, Mitsubishi's been somewhat of the standard in Colorado, but I'll mention later we're changing refrigerants. And actually that's helped some of the other manufacturers checking Lennox, Carrier, et cetera, minus 15 to minus 20. And these are generally what's required for all electric system rebates. There's some rebates for these depending on the utility. So I think let's talk a little more detail, dig into the weeds a little bit, because I think understanding this will help you when talking to your contractors and really just getting a better feel for things. So the first thing over here, which surprised me when I put this together 10 years ago or more, was this is outdoor temperature. I don't know if you can see it, minus 20 to 70. And this is the percentage of the annual heating energy use in each 5-degree bin. The point here is 1/3 of the heating is above 35, our annual heating. Half of our annual heating is between 15 and 35. And this is an Eagle. In Denver, this would be shifted a little to the right. And then 1/5 is below 15. I think initially people would have thought like the orange and the blue would be reversed. So over here is you've got minus 20 degrees to 60 outdoor. And this is called the coefficient of performance. And that's how efficient a system is at delivering heat. So for every 1 unit of energy in, how many units of heating energy come out? And I used HSPF2. That's like over a season. This is any given point in time. And what you want to look at here is this dark blue line goes from the upper right to the lower left. That is an air source heat pump. And notice when it's warm out, it can give you anywhere from 3 to 5 units of heating energy for every 1 unit of electrical energy put in. And that's this 1/3 up here. So that's a big difference. And then we've got in the middle, and then we've got on this left end from 2.5, close to 2.25 down to 1.25. That's how much energy you could pull out of colder air. These flat lines here, that's the amount of heating efficiency. The dark one is electric, which is the COP01. Basically put electricity into a resistive heater, it gives out. 0.95 is the orange, that's a furnace. I don't care what the outdoor temperature is. Basically, that's what they run at. So in this light blue line, just so you know, that's air, that's called hydronic heat pumps. That's air to water. And I'll talk more detail about those in the last seminar of the season. Here, over in this side, in this 1/3, heat pumps are normally lower cost to heat than natural gas furnaces. Normally, I spend a lot of time trying to pick the right word. What I mean by that is generally, if gas is sold at break even or profit, heat pumps are lower cost because there's big energy. Some years gas is sold at losses, and you can look at the last decade or so at the prices in the stocks and figure that out. So generally here, 1/3 heat pumps lower cost. Over here, gas furnaces, look at it, lower cost because I don't have as much energy advantage. So I've got gas here. In the middle, this big area, 50%, I'm going to say I would characterize it as pretty much even in Colorado. Different states could be different. Depends on the ratio. But it's pretty much in any given year can be plus or minus 10%, which isn't a huge amount on your bills. And it just depends on the costs of those fuels in that given year. And it does bounce around, especially the gas. So continuing on now, let's talk a little bit about dual fuel or all electric. What's the heating strategies? Let's look on the right side here with this graph I've been showing. So what happens here with the dual fuel in existing homes, typically heat pump will go down to about anywhere from 25 to 15. You can get to 15. I'll talk about the ducting. That's really the constraint. And then you go to a furnace. In all electric, you go heat pump down to about 5 degrees, and you've got a combo. What I mean by combo is you don't even know this is happening. Inside the unit, the controls are saying, give me the heat pump, add some electrical strip in because I need a little more juice. And then when you get below the outdoor operating temperature, which is usually minus 13 to minus 20, so this might barely come into play, and it's only a few hours a year, you would go with the E-strip. And this is just putting this on kind of the months of the year. I'm not going to go through that. You can look at that when you get the slides. So how much of the heating bill will my heat pump provide, and how much will be secondary? And so this is important because you'll be wondering about this. So this is called the outdoor temperature changeover from heat pump to furnace, or basically the supplemental. So this is the outdoor temperature. And the more you can run the heat pump, the more you get out of it. And so 25, 20, 15, 10, 5. So I go to furnace at 25, I get 63% heat pump. The furnace will be 37%. Notice the number of the run time. So percentage of the heat pump running, it's only 20% in the backup. So you go down lower and lower, and you get to 5 degrees. Well, that's 94% of the heating. Only 3% of the run times below that. And you got 94%. And this is what's really important, and I'll mention it a few times in the talk, is your duct system. They're designed for hot air. So this yellow arrow and this yellow, with a furnace, I don't have to change my ducts. I can just have it flip over. But if you're going to go to this effort, it's good to try to get as much out of the heat pump as you can. So, and in fact, generally it makes the house more comfortable if they look at doing this. So with minor duct changes, you can get this down. So you can put a little bigger heat pump in, and basically minor duct, I'll talk about what they are, just a few things, and you can get more out of your heat pump. Now with electrical, you really need to do this because you don't want to run the electrical backup. So you need to do more significant changes, but you can now drop that. Your ducts can handle heating with the heat pump down to 5 degrees, down to 0. You put the cold climate in, and the heat pump's doing all the work, so the backups, the electric heating's not doing as much. So let's look at costs. And so this is the whole industry uses something called manual J8. That's sort of the accepted way to build a house in the computer, put as much as you can know about all the insulation, all the design, all the windows, and you model it. Now, manual J8 it's a model, so it's not necessarily going to reflect exactly what happens in the real world out there. However, it's the best we got. And when comparing one system to another, it's very consistent. And when you want to get cost, the most important thing, I don't think it's emphasized enough, is what you want to do is say, what do I use for gas and electric costs that will give me the most realistic, accurate answer for the next 5 years in the future? I mean, people don't know. These things go up and down, up and down. Using a given year is not accurate. There's years when gas is really low. There's years when gas is really high. Depending on which year I pick, I can change these percentages a lot. So what makes the most sense? Well, after a lot of discussions with folks, and you need to smooth out some years. So we've taken kind of the post-COVID 4 years, and we looked at the December average in Colorado. Where does this data come? This comes from the Energy Information Administration. So federal government every month has all the utilities send their residential prices for gas and electric to them. They compile it, you can download it, and you can take the average. And we use December. That's the biggest heating. Well, January is really the biggest heating month, but the data comes out like quarterly. So this is as close as, and they're very close. So we use the December numbers and we get the average of the gas. We get the average of the electricity. Propane depends on where you are. It's 2 to 3 times what gas is. So I've been conservative here. I've used 2 times. So we feel that this is the most stable way to look at the pricing because even though in a given year things go up and down, these industries have to sort of stay within what we call it a window of affordability, a bracket. So let's look here. This column, first one is just the gas furnace, 95%. It says for this house, these prices, this is what it costs to heat per unit. Column one is a cold climate heat pump with expensive supplemental, either propane or electric. Propane and electric would be about the same. And so the heat pump's doing almost all of it. And it's a little less, but you say, well, the fact is it's a lot less. Because remember, this is a gas price. I don't have 5 columns here. If you take propane and put it in here, this number's double. It's a ton on versus propane or electric. Now here we have a two-stage, a dual fuel, two-stage heat pump, not quite as efficient. I'm changing the temperature over at 20 degrees outdoor. And so it's really basically a wash. So what's happening is that 1/3 when it's mild out, heat pump's doing great, incredible. When it's really cold, gas is doing it. And in the middle, I kind of split it. And then the last one is an all electric cold climate heat pump, really high efficiency one. And what there with a little electric strip, I'm getting the most out of the heat pump I can. I'm driving it down, in this case, to zero. Uh-oh, hiccups. I had hiccups the whole time this afternoon I was practicing. Sorry about that. And notice a little bit less. And this is why when I characterize it, in general, at the moment, we're sort of washing it. So you say, well, okay, depending on saving a little bit versus gas, I can save a ton versus the other stuff. Wow, my hearing heat pumps are really expensive. Well, let's look at apples to apples furnace with an air conditioner. 20 around and heck, prices all over the place. We try our best. We get lots of data, constantly changing, but like say 20,000, there's really no much rebates. Sometimes you'll get a couple $100 back. I think Excel is at $250 to upgrade your furnace. So 1975, let's just. So heat pump system, all electric or dual fuel, and it depends on what level of heat pump you put in, but it's got a range going there. You've got utility rebates, local rebates. Diego started to talk about. They can be much bigger than these. Try to keep a median. Look at the utility rebates, big range. And I don't think was emphasized enough. Excel, that limited time rebate, that's a 1-year deal. That's kind of an experiment. Those are good. If you go back and look at those numbers, there's like 3x the normal rebates. So if you need it this year, I'd highly recommend it. The partner rebates vary a lot. So, you're pretty much close on here. The heat pumps range from a bit more to a bit less. These numbers could be bigger. They could be a lot less. And then you've got annual income qualified rebates, which could be a lot more. So depending on where you are and who you're with, I'd say the range from a little bit more to significant. So the energy savings, I kind of talked about this. Heat pump average COP over the years is about 3. So use only 1/3 the energy of other heating systems. 1/3 the energy. Doesn't matter if it's propane, electric, or gas. 1/3 the energy. But the cost is, a lot less versus the expensive ones. And as I talked about gas, I say on par plus or minus. Let's talk about, I don't have numbers for like the sulfur and the NOx and all that, but this is, many people use GHG to compare things. This is the 2022 annual CO2 for these different systems based on the Colorado utility average emission intensity, which says, okay, I'm putting electricity to these devices. How much CO2 am I putting out to deliver that? Notice a car is around here. So heat pumps, I mean, heating systems in cars are your biggest energy uses, and also, what produce the most pollution, etc. So back then, we still had some high emissions. Our state started from way down. I mean, we used a ton of coal. So we had it tougher than other regions of the country that had basically a lot more hydro. Cold climate heat pump was a little higher. Gas is here. The hybrids were down here. But now, 2027, and I'm telling you, the utilities are doing a great job. They're on target. 2025, they are on target for reducing their emissions intensity, and they haven't really given any indication of letting up. They've got very good ways to change the grid, irrelevant kind of the political situation and what you believe, because there's just the technology just keeps getting better and better. So they're on target. Notice what happens. Here's the purple. Everything's down lower. Holy Cross is quite amazing because they're way ahead of their targets. If you want to go and read their annual reports, talk to them about it. If you run Holy Cross, wow, I'd say they're almost leading the country. So if you're thinking about yourself and, how does this all compare? This is a nice diagram of how we use energy. Space heating is the big one. Cooling is a little bit lower. And, this is kind of average over the whole country. The front range would be a little lower here, higher, vice versa. But this is the big one, aside from your car. And so over 15 years, they're going to say 50 to 90% on emissions. And how does that come about? Well, that's taking these looking at Colorado and all the mission plans and saying, okay, what's the plans? How are trajectories doing? And to get to 75% reduction in carbon intensity for grids is we have technology. We can do it. The next 25% will be tough. So that's why this varies, but it's big numbers. So let's talk. I know you want to, okay. You're thinking about your heat pump. How do I get a good system? Because that's really what's key. So we're going to go through this step by step. What will you hear? Maybe I have this reversed. I should put this above that. But all right, they don't work when it's very cold. My house is kind of cold. Or the heat pump heating costs were much more than expected. Well, they didn't put in a higher capacity or efficiency heat pump. It was undersized, was poorly installed. I probably should have another one here called understanding utility costs, because sometimes, your electric bill goes up, but your gas goes way down dramatically. And the other thing is, I think this one here pops up when there's way too much dependency on the electric strip backup, on retrofits, and they get big bills in the winter, and that's just because it wasn't sized right. Or sometimes, and that's why I'm going to go through very carefully, your changeover temperatures, because the changeover temperatures might have been set too high. So this is nothing to do with these systems being able to do it. It's basically getting them right. So one of the other things people ask is, this is a hard one. Should I get rid of my furnace? It's working great. And this comes into account in a couple questions. One is, and this is maybe more in the front range than up in the high country. But, I got to replace my AC. Do I need to get rid of my furnace? The other one is, I really am thinking about it. pump system. I really want to do something. There's these rebates. I want to take advantage of all that. I want to like a better system. So if your furnace is 17 years or older, actually it's time. Get a match system. The electronics will work, the controls will work. And talk to your contractor about a couple different levels. Okay, hey, can I do all electric, dual fuel, different levels, costs and benefits. So if it's less than 17 years and has what's called an ECM fan motor, so there's two different kind of fan motors. This one's a lot more efficient than this one, like 1/3 the energy. And so that's a big difference. I recommend keeping your furnace and purchase the heat pump from the same manufacturer if possible, and discuss with the contractor, is it a good match? Do they match? Do they work well together? The one neutral company that seems to have it that can retro with lots of different manufacturers is Bosch. I've heard good things about them in retro scenarios. If it's longer than 10 years and does not have an ECM motor, has it called the PSC, you can upgrade that motor. It doesn't cost a lot, and it's probably worth keeping the furnace. And then you get the manufacturer, and you get a nice system. 11 to 16 is a tough deal. You can upgrade the motor. I would discuss with the contractor and say, what's the condition of this furnace? Is it in good condition? Is it, also big differences. Is it a 90% furnace? Is it an 80% furnace? I guess I should add that in here. Because an 80% furnace, that's another big variable. So this is kind of the area where I think extensive discussion and deciding, what can you afford given all the rebates. So should I go all electric or dual fuel? And this is just a summary of the differences. The heat pump needs to be sized to fully heat your home at 10F or lower. You can read these later, just sort of a couple backups. The duct system needs to be upgraded or upsized because they're not adequate to fully heat your home below 20. And if you leave it at that, you're going to spend too much on electric. You may need to upsize your panel. The reason here is you're going to have your heat pump electrical and an electric strip. And I'll talk a little bit more about how to keep the electric strip needs down. And then you eliminate gas, but you eliminate gas for heating. And if you're on a path toward all electric, which will be kind of covered in the next webinar with weatherization, that's a big advantage. Dual fuel, you can heat it to 20F, and because the cost of gas is within a bracket, it's not going to blow your bill out of the water. And it matches kind of the existing duct capacity. You might need some small modification. I'll talk a little bit more about the couple things. Electrical system is likely adequate. You only need it for one device. And you still need to maintain gas, but you do cut the gas use way back. So how do I size the heat pump will work in my home without changes? And that's where you want this first one. You want to talk to your dismissing my time 30 minutes. So you want to say what's the electrician is a key to start, because the heat pump, your contractors need to be a good idea and say, well, I need this much. I need these two circuits for the electrical, one circuit if it's a dual fuel. So do I have enough juice in my panel? Panel upgrades aren't cheap. Lately, the utilities have been doing some rebates on panel upgrades. And this is what are your future plans? Is now a good time to upgrade? And I'll talk more about it in the next talk about thinking about the plan and when it might make sense to upgrade. And the duct system is what I've talked about a little bit more, and it's because of the air temperature differences, needs to carry the same amount of heat to a room as So they have to be larger. If you're doing ducts for a new home with a heat pump, it's about 30% more, which sounds like, God, that's incredible, but it basically means an inch or two on the trunk line. Not a lot, but big deal. I'm not going to go through all this. This kind of gives sizes and breakers. And like I said, your contractor can dial in a little more. But just so you know, you only have 100 amp. You're not going to be able to get a big heat pump. 150 should be doable. Depends a little bit on the backup if you're all electric. 200 amp. Now, one thing is, if you do have EV charging, it's or you plan on it, you put in it's good to share that circuit with the backup. That would be a smart panel. But the other thing is there's off-the-shelf device called Simple Switch, which you can put in both of them one switch. Smart electrical panels, talk to your utility provider about this financial technical support, and I think talk to your contractor, because this is coming, but I would want to make sure everyone's comfortable before I do that. So this is sort of guides on ducts. If you have an existing AC unit, usually you can upsize. Like you can go to the AC unit and look at it, and you can usually go a half-ton bigger with the existing ducts if you're keeping, a furnace system. It's kind of a fast way to get an idea. So if I have a 3-ton AC, I can probably do a 3.5-ton without tweaking the ducts. If you don't have an AC, the heat pump's going to be roughly half the furnace size. So furnace is 80,000. Basically, you can do a 40,000 BTU for heat pump. And here's the minor duct changes that I've been mentioning with a dual fuel to move and get a little more out of the heat pump. It's usually a couple supplies, adding a couple supplies, and adding 1 or 2 returns. The returns are usually easy to fit in. You don't necessarily change the ducts, but you just got to get 1 or 2 returns. They're not too hard to find places. The supplies sometimes is tricky. If you need bigger ones, like trunk lines have to be expanded or something, then it takes a little bit more effort. So before I talk about sizing more detail, I want to make sure everyone understands the terminology. BTUs per hour, how much heating does my home need? Basically, that is in thousands. Furnace size terminology matches that. If you look on furnace serial numbers, etc., they match this. Heat pumps, an AC go into tons. Heating tons, old English system term measurements. 2 tons is, so 12,000 is a ton. So you got 2, 2.5, 3, 3.5, 4. There are some cold climates that can go up to 5, but it's more limited model availability. And if you look at the model numbers, you'll see these in there. 02430, you'll see these somewhere buried in the middle of the model. So manual J is how everyone goes about sizing these systems. And you've got minus 30 on the bottom, out temperature to 70, and you've got 0 to 60,000 amount of heating the house needs and what the units can put out. And this is hours per year. And I'll talk about that at the end on the right axis. So this straight red line going up the middle is, what the manual J would be for kind of a typical home. Now, I've got a pink area here. Realize none of this. So some people say manual J oversizes some. You might have a little better performing house. Okay, so you've got kind of this range. And in fact, over time, yes, you kind of got this range. Most people are conservative and they, make sure that they're not underdoing this. Now, over here, the dark green is the cold climate unit factory specs. Wow, that's nice. That's sitting on a floor in a nice factory, fed the perfect air temperature with short refrigerant lines, fan working great, everything's fun, perfect. Field performance is going to be less over time and in conditions. If you've got a really harsh, windy conditions, super cold, maybe your line sets are a little longer. Maybe they're not perfectly straight. So you've got this band of operating in your heat pumps. So what you want to do, and when design, like if I'm doing, say, a cold, there's a couple things here. So if I'm doing a cold, let's talk about this. I want to have it intersect down around 5 to -5. This is the intersection I'm looking for. If it's a dual fuel, I can be looking at an intersection out here because their capacity is going to drop off out by 20 or 30 degrees. And I should have actually put that in. I'll have to add that in. So you want to do this in here. Now realize what's going on is this little bit here is your supplemental. And so my heat pump might go to -13. Like I said, I just looked up with the new refrigerant, -15, -20. So it's tailing off. My supplemental gas, I don't worry about it. I just set the by a furnace, it does this much heat. Electrical, I want it to make up this. I want it to make up this difference. I don't want to overdo it. So now, I get out here and say, well, gosh, how often am I out? How often am I really out here heating? Well, this thin line here is the average number over a 30-year climate data, the number of hours that you're heating when it's in this temperature bands. And notice here, it's like all below 20 hours. And the way I like to think about this, and I've got a bracket, 10% up, 10% lower on a given winter. The way I like to think about it is, if we've got one polar vortex, you've got maybe 3 nights. It's below there. And if you've got 2 polar vortexes, you've got maybe 2. So it's not a lot of hours at all. And in fact, your house is going to stay great during the day, and then things are going to have to work a little bit harder at night. It might fall off a little bit, but you'll be fine. So that's how they're going to size. They're going to look at this and say, what unit size will get me in here with confidence so I don't have too much of this electrical strip in here. And if I'm dual fuel, I'm coming down here. The ducts are the constraint. If I don't want to, if the ducts aren't going to get changed, it's going to basically come in around here at 20 degrees. If I change the ducts more, okay, I can put in a little bigger unit, get it down to 10, 15, and I can use more heat pump. So I don't like to usually read through this thing. I'm going to highlight, this is like the critical, this is kind of the summary of the really critical points. So all electric, got to get the heat pump so it does most of the work. You're going to have to fix the ducts. And so what should you ask them? Well, what do you need? What ducts are we going to do? How much is the cost? What's the lowest operating temperature for the heat pump? Should be in the range of -10 to -20. It's not, that's not good enough. Now, this is big. What size electrical strip are you recommending to assist the heat? And it should be 8 kW or less. This might help you from your point of view. This might help you fit it into the panel without worrying about upgrades. And if it's more than that, then you can upsize it by 1/2 ton. The other thing is, it's not so much on individual. The utilities can't have everyone putting in massive backups because they have to size. If you say I'm going to put in a 15 or 20K strip, I can afford it, I can get it in my panel. That's not good. The utility, it has to design your lines in. The local transformers have to be upsized. It's giant social costs for all of us. Will I be able to adjust the how hatred is it to how hard is it to? So that's important because you might want to. He might say, "Well, I'm going to set it to 30, or I'm going to set it to 5." You might say, "Well, how do I change it to minus?" and make sure that the system, just confirm that it's compensated for altitude. Um, and then for let's see, for gas systems, the slide got dropped out. It's just similar things. Basically, what's the changeover temperature? Should be 20, 25 to 15. Is the furnace size to handle temperatures to minus 20? And what minor duct system changes the way. So here is how do I know I'm getting a good heat, like the actual system? So what's the HSPF2? The higher the better. The higher the number, the better. What's the SEER? The higher, better. Really, you want to care about this. This tags along. This is kind of a tag along. For our climate, this is the big one because we only use about 1/3 the energy cooling is heat. Does it operate at outdoor temperatures at least to zero? What's the warranty, particular compression warranty? To the contractors, are they super comfortable with their brand? Are the distributors in Colorado, and does it meet the rebates? So the duct system checks and improvements. If you're going to go through all this effort, and I know a lot of folks say, well, this one's, the attic and the crawl space in the basement, if it's unconditioned, make sure that they're well insulated. Check the joints, leak tested. Sometimes you can do a leak test, sometimes not, but really they got to make sure they tape the joints right. We've talked about this a lot. Consider adding zoning if you've got a main trunk line that's accessible in the basement and you've only got one thermostat on the main floor or to the whole house. Ask them, is there a way that I can put dampers in without too much work and have two zones, help you in comfort, and it also help you in energy. I need to bring up fresh air system. We're almost out of time. We are over time. So if you're going to do this, you need with energy recovery ventilation systems are super good. What does that do? It's a way where you bring in cold air from the outside, a little bit, only a few percent of the air from the warm that's already warmed or cooled comes in, and it exchanges and it heats up this air coming in and can bring in fresh air, distribute it through the house all the time without a lot of extra energy. And it can be integrated with your air handler. So you should definitely ask about that. Good outdoor installation. On the south side, the other sides are fine. You just want to avoid the north. Can you put some softer, hard landscaping to protect from the west winds? Noise, getting better and better. Think of this as kind of an air conditioner, though it ramps up and down a lot better. So I don't put it right next to the patios or the under bedroom windows. Sometimes you put it on walls up here. You do a good job vibration clamping, but make sure it's near like outside of a bathroom or something. You got to mount it at above snow depth, put a snow shelter on top, and you want to make sure the line sets are done well and a pan heater to effectively drain it well. And contractors, is Friends, Diego, Walking Mountains, all these organizations, really good recommendations. Do they have certifications from the manufacturers? This is a big one. Do they really emphasize heat pumps on their website? Do they even talk about it? Do they install a lot? They certify. Get a couple quotes. If they're more than 10% part, I try to get a third quote. I'd be very cautious of low quotes. But if one's low and one's super high, I'd get the third. And it's unreasonable to compare online pricing, contractor bids. Playing off that a little bit. If you get a contractor purchase, you get support at all these levels. A lot of people think, well, I'm going to go online and just grab something, see if I can get somebody to put it in. This is a big deal. These are supposed to last 15 years. So you want to have support. This is the summary I'm going to skip over that. You can read about it, basically everything I've said. A heat pump water heater, just quickly, there's a special seminar on this, but it draws air from a room and extracts heat. Think of it as sipping heat from the room. It can drop the temperature in the room, but only a few degrees. So these are normally in mechanical rooms or closets where you don't necessarily care if it goes down 5 or 10 degrees. It's kind of the way I like to think about it is extra heat in your house that you draw on sometimes. You don't really need it, but it's very efficient, uses 1/3 the energy. Um, and it has standard electric elements in it too, if ever needed. So there's 3 modes to this: all heat pump, hybrid, which means heat pump plus some supplemental, or you can even flip it to all electric. And it cuts the heating bill uh, a lot for if you have electric or propane, about the same for gas, depending. So here's like an install versus gas or electric, pretty much similar. You got to make sure sometimes the room can be a little tricky because here you tend to, versus gas, you might want to upsize this a bit because it doesn't quite have the first hour capacity. Um, Basically, you need about 800 cubic feet, or you can install louvered door or wall grills in your mechanical room, or you can do an 8-inch duct to adjacent bigger room. So the exhaust is a bit cool. Keep in mind for location. So if you've got it near a basement hallway or some other room you don't go in, a storage, you can duct it. That'll help a lot. And I wouldn't duct it into my TV room or bedrooms. It's not recommended for research mode. So there's a whole webinar that a couple things. So that just wanted to sort of give a little teaser on that. So thank you. Sorry we ran over, but we're here and we're available for questions if folks want to hang around, have some questions.
Yeah, thanks so much, Dave. Appreciate the super informative presentation here. I believe we do have one question from somebody, and they ask, can a heat pump replace a gas boiler that heats water for heating homes?
Yes, it can. There's 2 options for that. Um, and that is you can have what's called a hydronic heat pump system. So the outdoor unit is air, but rather than go into like a air handler, it goes into a heat exchanger and it can create hot water. And the other is a ground source heat pump system. In the last webinar, I talk about options for heating homes with radiant. You have to have radiant inflow. You can't have um, you can't have like baseboard and stuff because the water temperature of these heat pump units you want to run at around 110 for it to be efficient. They just, as of yet, the technology's coming. It will be here within a few years for higher temps, but it's not here right now. And I'll talk about in the last webinar. I also talk about supplementing it with mini split systems. That's another interesting strategy where you keep your radiant system in, but you use it a lot less of the year. You don't hardly need it near as much. So last webinar, I go into those strategies.
Okay, thanks, Dave. I'm not seeing any other questions here. If there are any, please feel free to type them into the Q&A or the chat right now, or you can raise your hand. I can allow you to talk.
And you can always reach out to me for specific project questions if you've got a project you're thinking about.
Yeah, thanks, Dave.
Like I said, if you're on Excel, I would recommend looking at it this year. Their rebates are quite generous. I would be shocked if they extend them for multiple years.
Yeah, yeah, Excel does have those great time limited rebates for cold climate heat pumps. So Um, well, I'm not seeing any more questions right now, so
Thank you, everyone.
yeah,
Sorry
I
we
think
kept you over dinner time.
we can wrap it up now. But if you have any other questions, please reach out to us. We're happy to help in any way we can. And if you have any feedback for us, we'd really appreciate it. You can scan this QR code that you see on the screen, fill out a short survey, um, and we'd use those results to improve our future webinar offerings. So any feedback is helpful. Um, but we will go ahead and wrap this up. So thanks again, Dave. Thank you to all of our sponsors, and thank you to everybody who tuned in tonight. We will follow up with recordings, slides, and some additional information about all of the local programs or heat pumps. So, Dave, thanks again, and we
Thanks,
will see
Diego.
you again next week.
Absolutely.
Have a great night, everybody.